Hello, hello. Okay, let's get situated here. All right, I wanted to do a quick live stream today to show how to make your own custom functions in TidalCycles. And this might be a quick little stream. I don't know if this will be too long. Well, hello. Thanks for joining. So yeah, I haven't streamed for a while. It's been a few weeks. I caught the streaming bug a while ago, and then I stopped. Anyway, we're gonna start again today. So let me know how the audio levels are, if they're if they're not sounding good with the samples and sound. So all right, we're gonna create some custom functions. So custom functions are useful if you want to, I guess, personalize your Tidal live coding style, I guess, or your sound. If there's certain things you find yourself doing a lot when you're typing a lot and you're repeating yourself, that's a great case to make a custom function. I've got a whole file of functions that I use. I don't use all of these all the time. A lot of them maybe are pretty stale, and I should... wow, Euler Room joined. Nice. A lot of these are stale. I could probably maintain or get rid of some of these. But anyway, I've got a lot of functions I use that just automate a lot of stuff. So I think it's a useful thing to know how to do. So let's dig in. So let's say, let's just start with a pattern here. Boy, what samples do I have? I don't think I have the default samples loaded at the moment. Oh, I do. I can get the default samples. Let's do that. All right, so I'll load the default super dirt samples, and let's get ARPy in here. Let's get an ARPy pattern. All right, so let's do something simple. So let's say we wanted to, well, actually, before I get into deciding what we want to do, let's talk about how you actually create a function. So I am not a Haskell programmer, so I only know really how to do this in kind of a simple way, which is to use the let keyword, which is like defining a variable. So we can call it x, and we have to set x equal to something. So we can set x equal to anything we want. We can set it equal to a number and just evaluate that. So Shift Enter or Control Enter, depending on your editor. And then if I just evaluate x, you can see down in the post window output down here with the value of that function. So that's just something you can do with Haskell. We can just evaluate what a variable is. But you can also set a variable equal to a function itself. So let's set up a pattern here. So I've got a pattern of 8 ARPy samples, and I'm playing a run of 8 samples in the ARPy folder, so it makes this scale. So let's say I wanted to reverse that. I could create I could use the rev function to reverse that. But I could, just as a simple example, I can assign the value of x to rev and eval that. So now I've set x equal to rev, and my post window isn't catching up with me there. So now I can, instead of rev on my pattern, I can just do x. So now you can hear that x has the same effect as rev, and the pattern is playing backwards. I can even do something conditionally, like every 2x, and this will reverse or use x every 2 cycles. So that's as simple as it gets. You can just assign a function you know to another variable and then just use it like you would the regular function. So this is great even if you just want to make an alias. If there's a function that has a long name like striate, and you're really bad at typing striate, you could just call it x. And then you can use x in place of striate like an alias. That'll work as well. Oh, did I do something wrong? Oh, I didn't evaluate it. Man, my window is not catching up here. Okay. So now I've assigned x equal to striate, so I've made x the striate function. And so now I can give x the argument that striate would normally have. And I've created an alias. So that's another useful thing you can do. I've even done things where if I commonly mistype a function like striate, let's say if I do this a lot, where I mistype it, misspell it, I can just create an alias for the misspelling, and then I won't have to delete anything. It's just kind of a fast way of doing it. Okay, let's move on to the next level, level 2, which is to introduce some arguments into our function. So, and maybe we want to do something where we want to have a function that kind of wraps a couple other functions. So kind of jumping around here, but let's say I want a function that both reverses and changes the pitch. So let's say I want to do a function like, what's a good example? So here I've got a pattern where I am reversing the RPU sample, and I'm also multiplying the speed by 1.5. So this will pitch up the sample. So if I take out the speed part here, it plays at normal speed or normal pitch, and if I increase the playback speed, yeah, the GTFO function, we'll get to that. So let's say I wanted a wrapper function to do both the reverse and this speed change. I want to do both of these things. So you can simply just create a function that, my goodness, does both, like so. Why is this not? My scroll bar in my bottom window is not catching up, so it's kind of, yeah, I'm getting errors and I'm not seeing them. How do I keep it so it's locked down there? Anyway, I can't do this. When you start chaining functions together, you need to ultimately use a different, is it this? Oh, wow, I'm a terrible teacher today. There we go. Okay, so you have to specify kind of an ending argument to apply these functions to. You have to specify the pattern that you want to apply them to a pattern. So you need kind of a placeholder variable to apply these things on. So if I want my custom function to be x, I just use the letter P to say I want to apply x to a pattern. And then when I chain my functions together, I can just end with $P, and that will say, that's basically saying apply all these functions in order to P at the end. So now I can just say x, like so. So now I've created a shortcut function that does two things instead of just one. Now let's take it to the third level, and let's say I want to, I say let's say a lot, don't I? Is that weird? Let's say that I want to pass a value in for the speed I want to multiply by, and I'm going to call that I don't want to use n because n is a reserved function in Haskell or in Tidal. Let's just call it speed amount. And then in my function, I can specify an argument. So when you use the let keyword, I'm saying let x, which is my variable name, and then I'm giving a list of arguments. It's not a list, but an argument, a set of arguments I want to give x. So in this case, I'm specifying 2 arguments I'm going to give x: speed amount and a pattern. So if I eval that, now I can type a value in for x, or as the first argument to x, which is 1.5, and it will increase the playback speed of those samples. And I can change this to something else like 0.5. And I might be able to put a pattern in here. So whatever I put in x, I think it's just gonna, yeah, it's gonna accept a pattern. So I could even put in a pattern of values. Really, anything that the speed function accepts, I can type as the value for that argument. And again, the second argument of x is p, which is everything after x. So everything after this dollar, or at this $sign. So the sound and n, that's all this second parameter p. Not sure if this makes sense, but yeah, I guess this is getting a little bit into Haskell. I am not a Haskell programmer, so I'm probably doing a terrible job of explaining this. But again, all you need to do is define your function name. In this case, I'll say y, and then you can have any number of arguments after that that would be passed into the function, and then you can write your function. You can put, like I said, any number of arguments. So let's say, there I go again. You know, if I wanted a third, some other function in here, let's say, oh man, I keep saying that. Is that weird? I want another function in here called, or another, let's say I want to do another, some sort of transformation. We'll do, yeah, like striate, and then I'll just call it num. So let's neaten this up here a little bit. Indenting is important too. No, num. Oh, I forgot to put num. So I want to put a value in for striate. So then I need to put that argument in my function signature, like so. Now I've got my custom function. Now I got 2 variables, one called speed amount and one called num. And so now I have to put in a second argument here in my pattern. I'll just say 8. So I'll striate by 8. I can change that to 4, 12, 32. So you get the idea. You can chain as much as you want together. Let's see. So other things you might want to know. So there's a question on the GTFO function. So that is my mute function. So when I want to stop a pattern from playing, typically what I like to do is create stacks of patterns. Let's just start over here. So I'll have, let's say bass drum, and then a clap, something like this. So I've got a stack of stuff. So sometimes I want to mute one of these things. And there's a few ways you can mute things in Tidal. You can just set the gain equal to 0. So this will stop the bass drum pattern from playing. but it doesn't actually remove events from the TidalCycles stream of stuff that's going on. There are still 16 bass drums firing off. Even they just have a gain of 0, so you can't hear them. If you actually want to remove the events from the stream, you need to actually remove the pattern or override it. Anyway, I'm kind of getting ahead of myself. So to mute something, let's say I wanted to just set the gain to 0. My GTFO function is my mute function. And so you can do something as simple as gain 0. So now if I put GTFO in front of the bass drum, it stops it from playing. And if I remove GTFO, it plays again. So it's basically my mute function. So this is, rather than typing gain 0, it's fewer characters. I've even shortened this to just G. By the way, if you want to have multiple functions in line, you just put them on a new line and indent so that they're all starting at the same column in your editor. And I've got an alias G that equals GTFO, so I can just use G too. It's fewer characters. So that's my mute function. I actually have it defined differently. So my GTFO in my custom functions file is defined as this: a const and an empty sound. And this will actually remove the bass drum events from the pattern. So if I do that, so this is another way to do it. Instead of changing the gain, this will actually remove the pattern completely. Yeah. What's another example? There was something else. Oh, how do you evaluate functions when degrade by 1 actually removes events? Yeah, that will do it too. It's kind of a different question. Yeah, so there's a question about degrade by. So let's just shift gears and we'll talk about degrade by. So if I've got my pattern of bass drums here, yeah, you could do degrade by 1. That will remove all events also. That's an interesting way of thinking of it, yeah. So that will remove events. I'm trying to think if there's any side effects of doing it that way. I don't think so. I think, yeah, that would also work. I wonder if you do, yeah, that won't add them back. Yeah, you know, that's a great idea. Thank you for Liberties. I never thought of doing it that way. That would work, I think. Well, it certainly does work. I'm just wondering if Tidal is still somehow behind the scenes, keeping with degrade, if it's removing events or if it's still kind of keeping them in the stream somehow and doing more processing than you'd want. I've always thought that the const sound tilde will kind of remove all events from the stream, but I think degrade by is a good way to do it too. I think that'll do the exact same thing. I learned something today. Nice. That's cool. Okay. Okay, so the next thing I wanted to talk about was how do you, let's say you've got a whole bunch of functions defined. One thing you can do is, I just have a functions file that's right here, and I've got about 100 lines of custom functions. And each one is just defined on a new line. I've got a single let statement, and these are all in a block. So these are all my functions. And so I can evaluate all of these in just one eval key combination. So Control Enter. That will evaluate all of these functions at once. If you define functions with more than one let statement, so let's say I do this. So there's a title function called rev, a title function called jux. If I define them each with their own let statement, I can't evaluate the block. If I do Control Enter, I'll get an error. But if I instead indent appropriately and just use one let, I can evaluate the block this way. So that is correct. That is successful. So probably the easiest thing you can do is keep a custom functions file around if you've got a lot of functions, and just evaluate it as soon as your title environment is ready to go. This is the first thing I do. Other things you can do, if your editor supports it, if you're using VS Code, or if you're using Atom, there is a preference that you can. Where is it? So there is a TidalCycles boot title path that you can specify. If you have a custom .title file, you can put that path in here to evaluate your custom functions automatically. So on your editor startup, and on the title startup, it will look for a default boot file instead of you having to manually evaluate this stuff when it starts up. I personally prefer to just evaluate stuff in my own file rather than specifying a boot path. I gotta delete that, otherwise that won't work. But if you'd rather have everything just evaluate for you automatically, then you can create your own boot path and put your custom functions in there. So that will work too. I guess that's about it. I guess I kind of want to end with maybe an example of a type of function that I'm using a lot these days, or maybe some of my favorite functions that I've been using. One of my favorites is called rip, which will kind of provide creates like a reverse zipper type of effect. So what the heck does it do? It's a long function. So let's just break it out here. Then does this work? Okay. So I've got a function called rip, which accepts 3 arguments. The last argument is the pattern you want to apply it to, but the first 2 arguments are the A argument defines how loud the effect is, and then the second argument is how fast this zipping effect is. So let me get a pattern going here so you can kind of hear what it sounds like. All right, so there's the pattern. So now rip is kind of a more complex function. So I'm using within, which will affect just this the parts of the pattern between 25 and 75% of the cycle. And I am passing into within a couple other functions. I want it to slow the pattern down and then to call stut width. And it does some math where it will take that space between, or kind of this speed parameter b, divide by -8, which will cause the stutter to happen in reverse. And then I'm trying to remember what the heck I did in my function here. Gain. Oh, yeah, this is, it does the slow to, then the stut width, and then it also does the gain. So it multiplies the gain of each stuttered note by this A, which is a percentage. Okay, enough of that. So let's actually use this. If I say every 2 rip, something like this, I get kind of this zipper effect. And I can play with these values too. I can make the effect louder or slightly slower. Oops. Or faster. So it's just, I find creating your custom functions, as you play with things you like to do in Tidal, just make a function for them and then you can do them later. Or you reuse that effect later. Kind of another thing that I've been liking to do lately is to let me make a stack here. Is kind of make take a backbeat sound like this clap, and to have the clap kind of cascade up in pitch and lower in volume. And let's call it Cascade. We'll make a function called Cascade, and I think I do something like stut width. So I'll stutter the note 8 times at kind of a fast rate, and then I have to apply some function to it. So I'll multiply the gain so it gets quieter, and then I can also cause the speed to go up. So 8 there. So my stut width is getting 3 arguments. It's stuttering 8 times at a fast rate, and then I'm applying a kind of a multiplicative effect. I haven't used that word in a while. I'm multiplying the gain by 95%. So it's a 5% reduction on each stuttered note, and then each note also gets a 10% increase in pitch. So I can evaluate Cascade, and now I can put Cascade just on my clap. All right, so here's an important thing. What if I wanted to change how this Cascade function works internally and then have that be affected in the pattern? So while this is playing, if I change Cascade, let's say I want the stutter to go faster, and I evaluate Cascade, my pattern did not change. That's because it's kind of a feature of functional programming in Haskell, and also kind of a feature of Tidal in a way too. And that is that it's nothing is mutable. So when I change the Cascade function, that is not changing D1. D1 was evaluated with a previous version of Cascade. So if I want to change how Cascade works, I have to evaluate Cascade, and then I also have to evaluate D1. So now that I've done that, now my pattern will change. If I wanted it to be even faster, I need to eval the function, then eval the pattern. If you want to be able to do these just in one eval, you need to wrap them in a do statement. And let's indent, because we like to indent. So this is getting a little kind of crazy to read, but I've got under a do block, I now have a Cascade function, and then the pattern below that. So indentation is important. In this case, on my indent character, which is 4 spaces, by the way. Why not 2? It's configured tab size. Okay, all right, fine. Now, what'd I do? I think this indent is, what did I do? All right, okay. My square brace was not in the right place. So now if I change the speed of the stutter, I can just do it in one eval statement because it's under this do block. This isn't so much a function, but then you can also define variables in here, like for patterns. Just a pattern string, and then you can substitute that down in your pattern, like for your sample too. Wait, I did this wrong. Sound is BD, and then we'll set the gain to that pat pattern. There we go. So now I've got a custom function that I can tweak with live. I can live code my function and then have it applied to the pattern in just one eval. Make it go up and pitch some more. I can change my pattern. So hopefully you get the idea. You can, yeah, I'm gonna getting off topic with just defining a simple pattern variable here, but for custom functions, if you want to be able to live code them and have your pattern, your sound pattern, take them on immediately, you'll want to put them under a do block so that they'll evaluate together. Otherwise, if, like before, if they're separate, you'd need to eval the functions first and then also eval the pattern to have the function change take effect. So that's about all I wanted to talk about. Curious if there's any other questions while I think of something else to show. I'm just gonna kind of browse through. Are there any functions that any of you have seen that you thought were interesting that you wanted to talk about? We can talk about them. I've got another one that I use a lot called move, which will shift the cycle over by a quarter every third and fourth cycle. So I kind of do stuff like that. Again, these are things I found myself typing a lot, and so I just made a function for that stuff. Brak, this is my breakbeat cheat thing. Heck, I'm just going to keep talking about this stuff because it's fun. So I've got a folder. Let me bring up, let me show you this folder. No, where is it? One sec. I don't feel like stopping streaming, so I'm just going to keep talking. So there's, yeah, okay. So here's my custom samples folder, and I've got a few folders of breakbeats that I've pre-sliced. So here I've got a folder of 5 samples, and each sample is just a kind of an 1/8 note chunk of a beat. Any repos I'd recommend? Yeah, I know that Ben Gold and Kevin Bednar use a lot of their own functions. I think Kevin does. I mean, I know that Ben does. Let's see if we can track those down quick. I think. Yeah, I don't know if they have anything in their GitHub repositories. I'm just looking quick to see if I can find them. But I do know that Ben recently did a live stream where you can kind of see a lot of his functions in a kind of a live setting. Yeah, I can kind of show, like, here's an example. In this repository, there's some helper functions for scales, swing, the good old rip functions in here. So yeah, you can look at Kevin's stuff. There's also a good stream that Ben just did that Ben does a ton of custom stuff all over the place. So I want to try and find that quick here. Oh, where is it? Where is it? Where is it? There it is. Okay. I'm not sure if you can hear the audio in this. Maybe it doesn't have a lot of functions. I'm not sure if this audio is coming through for you or not. But yeah, if you kind of, let me just turn that off. If you kind of skim through his, maybe he doesn't define them inline so much. All right, we're gonna stalk Ben on his GitHub account. It's all open source, so I'm sure you won't mind. Title extra? I don't know. Where does he have this stuff? Atom startup. This looks good. Okay, yeah. Here's some stuff. Ben's got a few functions in here. Yeah. Okay. So to answer your question, do I know any good other sources of functions? I don't know very many. Okay. I want to show you this Brak function that I use. So I've got a few kind of like slice breakbeat things, and let me open up my DAW here so you can kind of see. So I just use my DAW as kind of a little mixer. I'll just put these chunks in my DAW so you can hear them play. Hopefully you can hear these. So I've got like a bass drum note there. What else do we have here? Snare drum. I think we've got like a hi-hat kind of thing. But these are all sliced from a breakbeat. And so they're very tempo specific. That's kind of the point. And so I can take those, so that's in this Akuma folder, Akuma 1. So, whoops. Hello? Oh, Akuma 1. So if I play this sample, and if my tempo in my title pattern is not exactly matching the tempo of the slices, it gets kind of strange. So if I set CPS to 1, so let's say I could do something like this. Oops. So I can manually get the tempo where I want, but what if instead I wanted a tempo like, you know, this? Or something that was faster. That, you know, that doesn't sound too bad, but I'm being really, really picky. All right, so let's say I wanted this tempo of half a cycle per second. These notes don't quite line up with the, to an eighth of a cycle. I've got 8 notes here, 8 events. They don't quite match. So to get them to match, you can have a sample match the unit of a cycle. Maybe format my code because that's what I do. And unit C, this will make every sample match a single length of a cycle. So if I just play this, they're gonna be pitched way down, and each of these notes is gonna stretch out to be a whole cycle. All right. So then I can set them to speed 8 to make them fit into an eighth of a cycle. So what I've done is I've essentially scaled, kind of changed the scaling of samples and how they're measured in a cycle, and then used speed to fit them appropriately to their size within the cycle. So now I've got code that can run at any speed, and the slices will match perfectly. And there's no overlapping, and the tempo is perfect. Okay, so I do this a lot. Unit C and speed 8. And so this is a perfect example of a custom function. So let's create it, or name it, I don't know, we'll just call it ASDF. And I just want to give it my sample name. And what this will do is it will play sample name. And yeah, we have to kind of do something. I haven't gotten into this yet, but we have to put the functions before speed 8. So now I've got my, oh, that didn't work. I forgot my P. Forgot the P pattern. No, that didn't work either. What did I do wrong? Second argument, speed 8. What did I do wrong? It's my indentation. Yep. Nope. What am I doing wrong? Oh, C is a string, not a, there we go. Nope, that's not it either. Oh, what am I doing wrong here? Let's see, blah, 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 blah. How is my custom function defined? So I'm using the dot notation instead. That shouldn't matter. Unit C. I haven't talked about the dots yet. I was hoping to avoid that. Oh. There we go. Okay. I just had some, I think I can get away without the dots. Okay. No, this isn't quite right either. Sorry. Now yeah. I'm getting way off the... All right, so what we're going to do is we're going to define a pattern in this custom function. So in this, I guess this is where I was kind of headed before, and we'll do unit C, speed 8. So we'll just make it as a pattern. And we are going to do density 8. And then we're also going to do kind of a random, pick a random sample from the folder. All right, really going down a rabbit hole here. Okay, so that works. So now I have a function. All I have to do is specify a sample name, which is a folder of sliced beats, and then it will automatically randomly pick a sample from that folder, stretch each sample to be 1 cycle, and then it'll pitch it up and multiply the speed by 8 to then scale it down to 1/8 of a cycle. And my pattern here, the sound pattern, only plays 1 sample per cycle, so that then I'm also increasing the density of that pattern by 8. So now I should be able to just do ASDF QMO1. Will this work? Yes. And I can set my cycles per second to whatever I like. Heck, we could even do that was fun. Okay, so you get the idea. I was doing a lot of breakbeat slicing and trying to work with breakbeats, so it's a perfect case for making custom functions. I was doing the same thing all the time with my kind of technique with these breaks, and custom functions really saved the day. So I didn't have to type the same stuff all the time with unit and speed and so on. And as you can hear in this specific case, it responds to the tempo change, which is fun. But that's a whole different topic. I want to do a future stream just on CPS, because it's nuts. It's a new function in Tidal 1.0, and it's absolutely nuts. I did a past tutorial on elastic time stretching stuff, and CPS just completely it doesn't invalidate that tutorial, but it takes it to a whole new level. It's amazing. I'm in a great mood right now. I'm gonna have some coffee. Any other questions? If not, I think I'll wrap it up. I'll just pause a moment and wait and see if any questions come in. But yeah, there's other ways you can create custom functions. There's another example, and it was in Ben's custom functions stuff, where if you want, you can include some type information in your function signatures, like this on line 7. And what this does, I guess from more of a pure Haskell standpoint, is you can then put some type. You basically are baking some type information into your function. In fact, is it T? Yeah. So for any title function, you can do :T and then a function name, and that will give you the type signature. So if I do this for the custom function I made, if I do ASDF, oh yeah, it does. It implicitly knows. How does it know what my function is? What the type signature is? Do rip. Yeah, so here's rip. Okay, so it implicitly, it derives what the type signature is. All right, I was going to say something probably very wrong, which is that when you define functions with a signature first, that you're able to bake that signature in. And the way I was doing it with let, you can't do that, but I guess I'm wrong. I'm not sure why you would want to do this. And I'm not the right person to explain that, because I don't know Haskell. I don't know why you'd want to define the signature separately from the implementation. but that's my lack of understanding of Haskell. So, okay. All right. On that awful note of lack of knowledge, I'm going to wrap it up. So hopefully you enjoyed learning about custom functions, and thanks for tuning in, and I'll see you in the future.